Oh, geez. My camera's still frozen. Hi, everybody. Welcome to SlimDevOps number 69. I'm Peter, and I am frozen, so let me fix that. But I am joined here by Naina, our developer advocate. We are Slim.AI. Hi, Naina. How are you doing?
Doing pretty good. How are you?
I am great. I am just going to go kind of try to fix my camera here for a second. This is embarrassing to get started, but we'll get going here. I'll get this figured out. Nothing to worry about. What have you been up to recently, Nina?
Yeah. Recently been up to learning a bit more about vulnerability scanning and the importance of that for container images for improving security or finding out if there are vulnerabilities in your images, and also learning about how Slim is able to leverage certain tools to reveal that information to a developer. So that's like pretty helpful because I'm realizing that that is the important step before we harden and like optimize containers. So it's been
Cool.
pretty interesting.
Yeah. So you've been doing a heck of a lot of like vulnerability scanning. You've been looking into the different vulnerability scanners that we have available on the Slim platform and all of that kind of stuff. Have you learned anything like that kind of surprised you during that or anything?
So that surprised me. I didn't realize just how a lot of the foundations and the organizations and like the legal aspect of these scanning tools and what needs to be done around containers. I didn't realize how interconnected they were. So I've been learning more about those organizations from a bit of my research. I think what was the one? I think it's NIST,
Yeah.
National Institute Standards and Technology. Yeah.
Mhm. Yeah, NIST. So yeah, they're pretty
Mhm.
heavily involved in the National Vulnerabilities Database. So you've been going into the NIST briefings and all that kind of stuff.
Yeah, yeah, a lot of that and learning more about, the vectors and all of the ways, the vulnerability metrics essentially, how all of that is defined. So it's pretty cool.
Cool. All right. Well, look forward to hearing more about that on a future stream. Once you, I know you're writing some docs for us on that right now, and then maybe we'll pick your brain on that once you have a good handle on it, and you're like a vulnerability expert at that point. So,
Absolutely, that'd be fun.
all right,
Add
awesome.
that to
Well,
the list of ideas.
cool. Well, this show is about containers, and we're container enthusiasts here. We get a lot of people who watch us to hear about containers, and we're pretty excited today to be joined by a couple of container experts themselves. So I'm bringing in Samir and Valentin from the Canonical company, which of course publishes the Ubuntu project that everybody knows and loves. Hello, Samir. Hello, Valentin. How are you?
I'm fine. I'm really fine and very happy to be on this stream.
Yeah,
Hey,
yeah.
great to be here as well.
Yeah, great. Yeah, nice to meet you both. I feel like we've been talking about this stream for such a long time. It's so good to like see you guys live on stream and everything's working and even my camera's working now, so that's good. Um,
Yay.
but yeah, Samir, you've been in our community for a little bit, which is great. That's kind of how this came together. You were asking us some questions about a previous stream, and we were looking into some stuff, and then we found out that you're actually part of this like awesome container, container optimization, slim container type project that's been going on with Ubuntu that we've talked about a couple times on stream. So, but I know you told me that you're relatively new at Canonical, so I'm curious, like, how did you get into software development? How did you get to Canonical? Like, what's your path been?
Uh, I was doing engineering school in um, computer science because I really like computer science for like all my life basically. And after my study, I applied to Canonical
Mhm.
and I was accepted at Canonical. What now I'm working on the works team with Valentine as my project manager. And it's a really good team and really good company.
Yeah, okay, awesome. And
Nice.
did yeah, go ahead, Dana. Yeah, yeah. Did you like really get into containers while you were in school and like that kind of technology or like operating systems and all that kind of stuff, or was it new for you when you started at Canonical?
I already have some course about com operating system like Linux and things like this, and containers also, but it was more like introduction, like containers 101, for example. And at Canonical is really a deep in terms of technology and knowledge, and it's really great to learn with so many people because every day I can learn anything new, something soon. Sorry, something new, for example, and it's really great.
Yeah, okay. Awesome. Awesome. Well, that sounds good. And now, Valentin, you your title is as a product manager, but you write a lot of code. You're very highly technical. I feel like you're somebody like me that enjoys both the product side and the technical side. How did you get to Canonical? How did you get into your current role?
Yeah, no, that's a good one. I actually was doing software engineering before at IBM, but at some point I was like, no, I want to have kind of a broader vision of where we're going to and kind of have more influence there, while still having the technical part that was really important to me, and also getting to contribute to open source software. That was also one of the requirements, and that's how that led me to Canonical, looking after the container images because I came from a cloud native background. IBM was working on OpenShift and containers basically, so that's kind of a seamless transition there.
Yeah.
And yeah, no, it's actually it ties into an interesting story because when I joined Canonical, I was basically the first person there to care after and to look after Docker images and containers as such. You know, for a long time we've been doing snaps and LXD, but Docker, even though it's been there for almost 10 years now, actually. Yeah, it was still pretty new for Canonical to look after.
Yeah. Well, obviously the patron saint of the DevOps stream was over there. Did you overlap with Martin Wimpress while you were over there with Wimpy at Canonical?
Yeah, I did. Yeah, when he was still leading the Ubuntu desktop there, we got excited time together.
Nice. Well, excellent. Well, for people who are just joining the stream, we're SlimDevOps. We do a lot of work on containers. This stream is all about containers. We're about to dive into the Chisel project that Samir and Valentin have been working on. If you have questions, pop them into the chat. We'll get to them as we go through the demo. But generally just say hi in chat. We're a friendly group. If you find the content interesting, give us a follow. If you want to connect with Samir or Valentin afterwards, you can of course find them over in the Ubuntu and the Canonical communities, but they're also in our Discord, so you can join our Discord, which is over. I have to point to the different thing. I forgot I was mirrored. Slim.AI. Normally it's right above my head, so I can just do that. But Slim.AI. If you go over there, there's a link to our Discord, so feel free to drop into our Discord. But with that, maybe Valentin, let's start with you. Maybe you can just give us a quick overview, like what is Chisel? What does it do? Why did you guys kick it off? What was the thinking behind it? What's the origin story behind Chisel?
Yeah, I'm gonna try to tell you kind of a story of how it happened behind the scenes, if you want. Don't quote me on everything I say here.
Well, you are on live stream. I just want so we'll do what we can to keep it out of the public record, but it's kind of here. So give us the
public record secrets.
yeah. There we go. It's the secret for everybody. Everybody watching. This is just for you. This is just secret. So
exactly, just keep it for you.
Yeah.
So yeah, when I joined Canonical actually at the time, so the Ubuntu base image, of course, already existed. It has been here since the beginning of Docker, but it was coming from the community. Such as a lot of stuff that we are doing is coming from the community, so that was great, very exciting. It was actually the most used container image for quite a long time, especially when Docker was more like of a developer thing and very kind of experimental, not yet making it to production. So at the time we didn't really have that Alpine and BusyBox amount of consumption that we are seeing today. But yeah, Canonical was not doing anything for it, which is there's a fun fact here. And so when I joined, I was kind of doing a state of things, like how is it looking for us, kind of trying to grab some metrics of how we're doing well and what our users are doing with what we are shipping them. And we realized that, Ubuntu was very popular with developers, as we expected, so we're super happy here, but it was not making it to production because too big, basically. It was just the summary of it. we looked into it, like we were like, yeah, but they're wrong. You know, they're doing it because they want less attack surface. They want to be more secure. But they're wrong. Ubuntu is well maintained. We're doing things well. So yeah, that was basically the status quo. But that doesn't change anything to what we're shipping, and that doesn't change anything that people were not using Ubuntu images for production. So we thought there's something we must do here, and we looked at the options. We could have had the option as Alpine to kind of do a smaller version of Ubuntu, try to compress some of the packages there, try to remove some stuff. But it came up that probably distroless was the better project out there, the best project out there. At least technically speaking, like we really were admirers of distroless. But interestingly, like when we tried to look into it as well, and we reached out to the Google team that is doing and maintaining distroless, and we realized that they had very little adoption as well. Gaining some traction still, but I mean, it was like 2017 when they released it, and yeah, still very, very low usage, which was like a very surprising thing to us because technically, I mean, it's great. And so I'm probably I'm going to start sharing my screen from now just to try to illustrate some of the things I'm talking about. So just for the ones that don't really know what distroless is and what it does, I'll try to show you what, first of all, what we are doing, what we're doing at Ubuntu and what the distribution is. Well, a lot of you probably know more than me on this topic, but still I'm going to try to do a job of it. So basically, distribution is just a bunch of packages. So we could have, for example, I'm going to show the .NET one because this is one of the first ones that we looked after making containers out of it. So if you take just this package and you apt install it, what it does behind the scenes and what does make Ubuntu an interesting experience is that it grabs for you all of the dependencies that .NET can depend on. So you have like probably libc is one of their dependencies. You have like libgcc, there is another one. Like I'm not going to do the whole tree on screen.
There's only a few thousand
you
of
get
them.
the idea.
But yeah.
Exactly. And the point is that this is a boring picture. Like as a user, you don't really want to care about it. You just want to care about this because this is what I wanted to install. I wanted to install .NET to run my .NET applications. But still, behind the scenes, that's what we are doing. That's basically our job at Canonical, is to make sure that this tree is the best experience for you as a user, that when you install something and then something else, it all works together. You don't have any conflict. You don't have any weird error message or something. Like it could have been in the past when users were trying to move from Windows to Linux, and it was a bunch of just error messages. So what we're trying to do here is to avoid you this experience. And when you look into the packages themselves, that's also a very interesting world. It's like you don't really realize it, but basically what packages are is just a bunch of files that someone else organized for you in a very clean way. So they have like I don't know, a documentation file when you do the man pages of a package. There is some binaries as well.
Sure.
Of course, otherwise you would install nothing. And there are some libraries sometimes that are coming as part of the package, not as a dependency, depends how it was packaged. And so they're mentioning this for you. That's the great experience of a distro. What Google came up with at the time with distroless is, let's break this. We don't need this in container images. We want to make them smaller. We want to reduce the attack surface. And one way we're going to do this is just by basically removing dependencies. For example, like let's say, I don't know if that's a good example. Yes, I think we could remove it for running in a container because the GCC is at build time. We could, if you're not doing, I don't know, any, let's say this one is a crypt library, for example, and you're not doing any crypto, we could remove it. There's a bunch of files as well within the package that we could remove, like the documentation, the man pages. You're not going to use them at runtime in a container. Some libraries, I don't know if they don't make sense for the use case that you are packaging for. So that's basically what the maintainers of the distroless distribution have been doing by hand. And then you get like this Google distroless base image that is about like 10 megabytes, something like this. So very neat, very clean base image. But this is like expert work. Like you can't expect the end user to be doing that. So
well, and I can kind of interject that I think people who have watched us a lot know that we have an open source project that was formerly known as Docker Slim. Now it's SlimToolkit, and this was the same problem that our CTO at Slim.AI was looking to solve. taking a very different approach. And distroless has gotten a lot of more. I think it's gotten more popular over time. It was certainly hard for people to understand early days. But a lot of the people from distroless then left and went and formed ChainGuard, and so there's various people kind of trying to solve this problem. So it's awesome to see kind of you guys getting into it, and like this pain point that you're describing is a pain point we hear from everybody, right? Like, I mean, this is the pain point with containers. So
yeah, it's a pretty good point to make. That yeah, we are solving the same problem. And actually, when we were at this stage, we were like, okay, so that's distroless, that's this great idea. We have Ubuntu, we want to reduce the size of it. How can we do it? One of the options was doing what you guys are doing. It was like, just let's go from the top to the bottom by removing the stuff we don't need. And we thought, yeah, but there are solutions for this. Like, actually, at the time, we quickly chatted with you guys, and we were like, there are solutions for it. They're probably great. But it seems that still we have an issue because they don't really take Ubuntu and trim or slim it. So maybe there's still something we could do. And being the one doing the trimming or the slimming on our end didn't feel like the right solution, because it's not what like our kind of nature or brand.
Yeah, it's not like
something that can
Ubuntu.
happen later in the pipeline.
Yeah.
Exactly. Like, we wanted to keep into the feel of the distribution, so that you feel that you're in the distro, even though afterwards, if you want, you can make it distroless for shipping it to production. But still, we wanted to make you feel like you're in the distribution. So we thought, like, if the Slim.AI folks are going top to bottom, what couldn't we could go the other way, so bottom up, and basically take this picture that you have on screen and build the kind of layer on top of the distribution that carries out this knowledge. So the expert knowledge that says, if you want to install this part, only this part of the package, then you don't have like this dependency and you don't have these other files. So that's exactly what we did. Basically, we created this Chisel tool that you mentioned, along with what we call Chisel releases, that are a layer of knowledge on top of the Linux, on top of the Ubuntu distribution. So we use the upstream, the package, and apt knowledge, the information there. But on top of that, we layer the extra information that would usually be done by distroless type images maintainers in a file that is very similar to a distribution. So that basically we can remove all of this complexity for the user, and you just have to do like you would do apt install. You just have to do chisel cut. In that case, that was the .NET runtime image, and install it like this, and say I want just the binaries out of it.
Okay.
So you're combining two things. This thing is the knowledge we already had in Ubuntu. This is the apt, the package database. And the right hand is the new thing. It's the chisel part, really. With this idea that, I mean, we thought a lot, like, what would be the best base image? And we always came out to the same conclusion that was like, there's no ideal base image. Someone is always going to ask for something more. Someone is always going to ask for something less. So the only perfect base image is Scratch, with just nothing. But you need a package manager to do some stuff on top and build something that then you can want to even more reduce. But at least you have something neat that you know is just what you wanted to put in your container, and then move forward from here. So that is, let's see if I can do that. So that is what we did here. So this is the blog that we have on the Ubuntu blog. Actually, I wanted to share the other one first. This is the first thing that happened is this one. We did it with Microsoft, because as I said, like, you can't really chisel one version of Ubuntu, or you can't really make one base of Ubuntu, because there's no perfect base. So you have to do it for something specific. And in that case, so at the time we were already chatting with the Microsoft.NET folks for bringing .NET, the open source framework that they have, into Ubuntu. So we were like, hey, do you want to be on with this new thing that we're doing, that we're calling Chisel, and do the first Chiselled Ubuntu for your .NET platform? And hence we did. And so then there's this other blog on the Ubuntu blog that is describing exactly how it works, what's behind the scenes. So that's probably a good follow-up to the introduction I made here. And you see that in the end, it got us very closely to the Alpine or distroless of this world, with still having the Ubuntu image for your development. So we have two demos that we want to show you to show how it works. The first one is just really focused on Chisel itself, just how you can use it in a Docker file that Samir is going to show you. And then I have another one that is combining with Slim, because I do think it still makes sense in your pipeline, even if you're trying to have the most neat image from the beginning. Then you're layering stuff on top. You're layering your app. You're layering dependencies that are coming from elsewhere in the distribution. So you might still want to reduce it.
Oh, interesting. Okay, cool. That's a surprise. I didn't know you guys were doing that. That's super cool. I'm excited to see that. So, and that kind of gets to what you mean by like, so just to like double click on what you mean about, you know, kind of no perfect base image, right? Like if Naina's a Python developer and I'm a Node developer, right? Like we're not going to want the same base image. We're going to want different tools, different package managers, because we're going to be adding these applications in. And that's where things kind of usually go sideways. I was talking with someone recently who was like, yeah, we have a golden image. Well, actually we have multiple golden images. And then we have like a weird golden image for Go because Go is different. And you're like, okay, well, is that like a golden image? That's not a golden image. That's 3 images, you know? So I think this happens a lot. It's very often, it's hard to like just kind of zone in on a single base image that works for everybody.
Yeah, exactly. That's exactly the situation we've met. I mean, even for the images that we built with .NET, so we built them with the .NET team at Microsoft. So probably the best ones to decide where to go or should not go in the image. And when we released them, we got a lot of feedback that was like, hey, can you add just you know, the translations file? Can you add this extra library or this? No, we can't. We have this pre-built image that is for demonstrating what you can do. But the best thing you can do is craft your own, and it's just one command line because we did this chisel thing. So
cool. All right, yeah, let's take a look at it. Samir, are you gonna share? You're gonna share the.
Yeah, I'm gonna share my.
Yeah, I'll bring us back here for a second. Let me know when you're ready. That's super cool. Naina, anything? You're relatively new to this world. You've been working as a software engineer, building like web applications. You use Docker containers a bit, but you're kind of new to this world of container optimization, container slimming, container chiseling. Now we can put that in the lexicon. What's occurring to you? What's going through your mind as you kind of like look through what Valentin's trying to do?
Yeah, I was just thinking about, well, kind of what you had mentioned before, that this is a problem that many of us are running into and trying to solve. So it's interesting to see that there are different methods, I guess, for going about hardening or, making containers smaller. So it's pretty cool to see this from a different angle from what I've been looking at.
Yeah. I guess one question I have before we get into Samir's demo is like, has this changed anything with the Ubuntu latest image? Because Martin and I were looking at the 2204 image when it first came out. It was the first time I'd ever seen a base image with no vulnerabilities. That was like a first for me. I'd like literally never scanned an image and never seen 0 vulnerabilities, but that image did have 0 vulnerabilities. Has it changed anything with that? Like since you've been working on the Chisel project, like how do you see those two things like interacting like kind of long term?
Right. So the way we see it is like we need to keep the Ubuntu base image as something that is close to what it is today. So we're still trying to make it a bit smaller for some other reasons, like some stuff that was used to be in it has nothing to do in a container, so that we are getting rid of. But our answer to someone asking, we want a super small Ubuntu container to run into production, can you make it smaller? The answer is no, but you can now you can build your Chiselled Ubuntu, which is just a slice of Ubuntu that is exactly what you need for your production. The other thing that you might have noticed is that we're trying to take strong ownership of the image that we're shipping, even the full Ubuntu one, releasing it way more often to make sure it's always getting the latest updates. So that's true on Docker Hub, where we're collaborating with Docker because they are still owning their official images, and there's actually a lot of dependencies on the Ubuntu one. So if we rebuild it every day, that might have downstream consequences. And we are on ECR as well now, trying to be the closest to the usage.
Cool. Oh, that's awesome. That's good to know. Yeah, it's good to see you guys taking a lot of ownership there because, yeah, I know almost every app I've ever built has been built on the Ubuntu base image. So it's definitely a necessary one and not one you want dependencies changing on too much underneath you. So cool. Just a reminder to people in chat, feel free to jump in, ask questions, give comments, let us know what you think about Chisel if you've tried it. and ask questions for the team. I will go back over to the screen share. And Samir, are you ready? All right, here we go. Coding window up, and let's see how this works.
So this Docker file, so it's one Docker file. It was before Chisel. You can already, like, if I take the application of OpenSSL, the example of OpenSSL, right now it's just a way to build, like, you get the Ubuntu image, you want apt update, apt install in order to install OpenSSL, and the entry point. So it's really like 3 step. It's really simple, but you will have at the end a really big image. And here it's another Docker file with Chisel, which permit to reduce the size of the image, but it's a little more complicated if you use a little um, Docker file because it will use multi-stage build. But in order to explain each step, so this line permit just to uh, git clone Chisel. So you can see here we git clone Chisel with this URL. You can check on GitHub. It's a public repository. Like Valentin said, we have the Chisel release. It's a database which permit to know what file we can take for some package. It's here. It's a URL, and what it does, it's just like compile Chisel to have a package in order to after cut, so we slice the package. So this one, it's more like we will use Ubuntu to be the builder. So he just runs some apt-get with CS certificate, and he copies the chisel to /user/bin. So this one is more to do preparation, like we will add a user. So the user will call its name Ubuntu with the ID of 101. The group is Ubuntu. This one is more for the image preparation. We add the user and stuff like this. And
Mm-hmm.
right now it's like where we use Chisel. So with this line, what we does is really simple when user use it. But we say like, okay, so we have our database with all the package we can slice in Chisel release. It come from the GitHub repository, so Canonical Chisel release. And we want to have only the binary needed to launch OpenSSL. So
Okay.
it's this command. And this command will create a folder which name it rootfs. You can change the name if you want to call it Ubuntu, for example. You can create Ubuntu. If you want Samir, you can call it Samir. And inside this folder, you will have all the file, you have all the system file you need in order to launch OpenSSL. And here,
Okay.
what we do is just getting the rootfs folder, put it inside our image from scratch, and just entry point OpenSSL. So first, if I do like Docker image, because I already built this image,
Mm.
so here, so the Ubuntu, the OpenSSL tag Ubuntu is the classic one, so this one, and the Chisel one, it's this one. So what we can directly saw, it's like the difference of size. So one is 80 MB, and the another one is 11. So it's it's really a big difference in terms of size,
Cool.
and they have the same functionality. Like
Cool.
for example, if I just run this command, it will work. Like you see, connection established and done. And if I run the same command with Chisel, we'll have connection established and done. But the advantage is first the size, because we reduce the size uh, really big, like, and also it's consistent for the platform and dependency for development to production, because it will be like the same chisel image if you need OpenSSL for development or for production, because you will only have inside the Docker image, will only have the file needed to launch OpenSSL. And this command is really using apt, so it's consistent with apt experience. But some downside of it, because you have only the file for OpenSSL, and so you will not have apt-get at the end in the Docker image. You
Okay.
will not have ls, you will not have bash, for example. And because of this, it will be sometimes difficult to debug because you can just say like docker run /bin/bash into it and doing some command.
Yeah.
And also because one containers equal one task for this. Normally it's a good practice, but sometimes it can be a disadvantage. And right now, like, okay, so you saw all the Docker file. You have like 1, 2, 3, like uh, six image using, like from 6 from uh, command, and it's it's part of Docker to have multi-stage build, but for some people it's really complicated to do it. But it will be not today, I think. But if you use like another tool from Canonical, named Warcraft, it will be like more simpler to get the package from Chisel. You will not have a multi-stage build, but
Cool.
I think it's a good way. Like first, you will learn how to do multi-stage build, and the advantage to for the image, like at the end having an image of uh, 11 MB is really good and really worth like all the difficulty you will have to generate it. And right now
Can
I
I
will
can I
leave.
just
Yeah,
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 can
you
I
can
can
ask
I
a
just
question.
I think you said a lot of like really really interesting things. And first of all, like a like a 70 megabyte reduction from an 80 megabyte image is like that's pretty good. That's a pretty big percentage drop. I mean, that's very similar to things that we've seen with some of our tools in kind of best case scenarios. So I think that's a really awesome outcome. I want to make sure I'm understanding what it's doing. So basically what you did is in your Docker file, you did a multi-stage build. So you have this sort of like 6-stage multi-stage build. And in there you used some commands, some chisel commands in order to say like, hey, when this file is building for the chisel version, when I'm building the chisel version of it, I want you to only include these things, or I want you to only include binaries in this case. I was wondering if maybe you or Valentin could like, how does it know which binaries to keep? Because you mentioned it won't have apt-get, it won't have ls, it won't have sort of these standard commands that we know and love as Ubuntu people. Like, how does it know to do that? Is that like pre-programmed? Is that like reading the application and saying like, okay, I know that OpenSSL doesn't depend on ls running? Like, can you talk to us a little bit about how that like works?
Yeah, just yeah.
Yeah, I can also
So
take it, or as you want.
so when you build the image, like when you use the chisel command, you have access to apt, like to the apt get, apt update. You will have access to it. When I say like you don't have access to apt, it at the end when you, for example, when you do docker run, at the end you will not have. Uh, so you will not have like the apt command. But for example, when I say like OpenSSL bin, I want the OpenSSL bin. What you say is like we have a database of slice. Like if I go here
And in the
and
previous diagram, that's the layer on top of the distro that I was referring to.
Oh, okay,
So it's
cool.
currently
okay,
available on a GitHub registry with questions on where it's going to go next, because we wanted to live close to the packages, but also we don't want to correlate it too much, because you can use, of course, apt and dpkg as you used before, and this is just on top.
Okay, got it, got it.
Yeah.
thanks to this file, like to this YAML file, Chisel know what file you need to take it, what dependency you need, what file you need to push
Oh.
on the file system.
Okay, cool. Okay, cool, cool. That's really cool. So you guys are like creating this sort of mapping at the package manager level to say like, okay, we always know what OpenSSL is because it's in the package manager. So if you need OpenSSL, here's all the dependencies for OpenSSL, and anything that's not in that tree, like we're gonna get rid of when you go to chisel the container. The other stuff can stay in the previous development kind of style containers because you might need it to do something, but apt-get's not going to be in that tree, so we're going to get rid of it in the container. Did I explain that well? Like, is that a rehash of what you just told me? Yeah.
Exactly. And the idea is that this work that you described used to be done by image maintainers that wanted to do distroless at their level. And now we just shifted it to the package manager. So it still can be contributed by anyone in the community. You can even have your own definitions locally if you want. Cool. But ideally, as an end user, you just have to say, oh yeah, I want this slice of this because I know that's what I need to run my application. And that's it.
Cool. That's really cool. I hadn't realized that was how that is working, and that's a really interesting and novel approach to it. Because yeah, I mean, if you're using like from scratch, or if you're doing like distroless, right, then you're kind of doing all of this by hand in Docker file, and you have to do it when you develop the container, and then you have to undo it or redo it when you have your kind of production image, if I'm understanding that correctly. So you guys kind of provide some simple commands that already have the sort of mappings in there, and then it's just that one command that Samir was showing to chisel the container. That's cool. Well, yeah, if people have questions, we can get ready for the next thing you guys want to show. But if people have questions, please drop them in chat. If you're enjoying the content, please give us a follow. We always appreciate that. Nena, any questions from your side on what we've seen so far?
Yeah, I was just, I guess I wanted to know more about that file. I found it to be pretty interesting. If we could dig into, I saw like essentials and what was it, some of the other contents. Wanted to know more about how that was organized again.
Can you?
Yeah, do you want to? That was, and maybe you guys can give me, if you give me the GitHub repo, I can post it here in chat. What's the, so where can people find that on GitHub?
The GitHub repository for Chisel, it's canonical dash Chisel, and for the Chisel release, it's canonical slash Chisel dash release.
Yeah, okay, let me see if I can find that. I found the Chisel container, so cool. All right, so I'll put this in the chat, and if people have questions, they can let us know. Oh, shoot, oops. Cool. And cool. And Valentin, you said anybody can contribute to that. Is that right? So if people have their own like kind of notion of what might make a good SSL, like kind of full SSL package, or if they have their own packages that they're working on and they want to include them in Chisel, that's probably a better use case. And they say, okay, these are all the things that are required to run. These are things that are kind of nice but not necessary. Then they can submit a PR into that and kind of map their own images. Is that the idea with the community base?
Yeah, if that is for upstream packages that have not yet been chiseled or not the way you want it, because you might want a different slice of this package for a specific use case, then exactly, yeah, you can open a PR. And if it is like something, I mean, sometimes you're willing to fork and edit, but not to contribute yet back to the project because I don't know, it's in kind of a draft state or something. You can also do that. So you can also fork the releases project and use it locally from Chisel. So you don't have to use the upstream and wait for your PR to be accepted upstream. You can also fork and leave it on the fork for some time.
Oh, okay. Okay, cool. That's awesome. Nice. Very cool. All right, sounds good. Did you guys have more on that sort of first example that you wanted to highlight, or are we going to jump over into the Chisel plus Slim? Now you've just got me excited about this Chisel plus Slim demo that you've promised. So,
oh, we can pass on the demo with Docker Slim.
Yes.
Cool. All right.
Is it big enough, or do you want me to increase the font?
Yeah, no, that looks good. Yeah, you look great.
Perfect.
Yeah, if people in chat need it to be bigger or anything, let us know. But usually they're pretty vocal about it. So yeah.
Okay, sounds good. Okay, so what I'm going to show you is using pre-built images, but I want to have like a real use case so that we can then slim it. So something that is doing something. I'm using Java because it's the most recent one we're doing. It's like the edge of what we're developing. To give you kind of more vision into the roadmap and where we're going. We kind of need to chisel a lot of packages now. It's a subset of the Ubuntu distribution because you're not going to containerize all the packages that we have on Ubuntu. But we need to start somewhere. So we are starting at the runtime level because that's what is going to enable the most developers. So yeah, we are working on Java at the moment, and we just released the chiseled images for the Java runtime environment version 8 recently. So version 8 is an old one, but that's because it didn't have all JLang craziness. I mean, I didn't know what this means before, so if you're not a Java developer, just, Java is Java.
Yeah.
It's not
I
so
am not
sexy,
a
but
Java just a developer and don't ever want. I've never claimed to want to be. So, but I appreciate
it's
you
a good
doing a
language. Like,
Java
I
example. This may
used
be the
to
first
study.
Java example we've ever had on the SlimDevOps Twitch stream. So
It's been a few
maybe for
years
good
now.
Wow,
reason.
everyone does cool stuff like Node.js and Python. Why?
Yeah, the easy stuff. It's been a few years for you, Nena.
Yeah. The last time I saw this was like computer science courses, and that was an interesting introduction to this kind of coding.
I think there's something we need to clarify because every time I talk about Java, and that's the same thing for me. The last time was university, the computer science classes. So I don't understand how is it still one of the most used in production. Where are you, Java developers? But yeah, no, that's always an interesting. It's a very clean language. So basically, even if you're not into Java, you understand this program quite easily. Even it's doing some weird stuff, but it's always easier to understand than a inline JavaScript function with some fancy pipe stuff. All right, so yeah, just have this example of a Java program. I took this one because it's doing something very simple, but at the same time that requires some complexity. So it's visiting a web page, so the example.com web page, and it's visiting it using HTTPS. So it might look straightforward, but there's a lot involved behind the scenes. And if you remove too many packages from the distribution, a lot of this can fail at many different levels. Mostly the HTTPS one is adding all the crypto side, all the CA certificates validation. And of course, you need the Java runtime to run it. So what I'm going to do first is show you an example that I have already here of a Docker file that would be containerizing it in not too smart way, but very easy. Like I wrote this Docker file today very quickly for my Java application. So you're starting with one stage that is adding your source code on top of an image that has the JDK and compiling it to some class file. So just compiling your application basically. And then you have a second stage that is a runtime stage that is installing just the runtime headless. So hopefully the smallest version we have available as a package in Ubuntu. And doing some cleaning to try to do things well, but still it's not optimized. It's just an Ubuntu to Ubuntu. I could have done one stage even, but yeah, let's see that. So the idea is just to see first the size decrease, and then to do like if we were in a CD or CI and slimming it as well.
Cool.
So if I do build, let's call it Java, and well, that's it actually. I had cached it because otherwise we'd have all the apt install stuff going on.
Viewers, thank you for that. We know we don't have to fill dead air with Docker build and pulls running like we usually do. So thank you for that.
How did I got it? Yeah, I forgot the yes. That's the image we just built. That is about 200 megabytes. So yeah, that's actually a pretty common size in a Java application, even for a very simple one like this one that you're containerizing without any optimization. So what we're going to want to do now is to switch from just the Ubuntu classic image, so the one you used to know, to using a chiseled image. So we have one pre-built for Java, as I was saying, so I'm going to use it. It's published under the Ubuntu namespace on Docker Hub, so we can just do that. And we have like a semantic, we call semantic tagging for these images. So it gives you all the information you want from the tag. So we're just saying we're installing the version, pulling the version 8 on top of 22.04, so the latest Ubuntu long-term release. And it's an edge channel because we are still like in development or just releasing it.
Cool.
So I can get rid of all the apt install stuff because it's already built for me. Another demo that I could have made here, but that's basically what Samir did before, is I could have started with from scratch and then run Chisel install exactly as he showed you. But here we have a pre-built image, so we can just use it.
Okay, cool.
So yeah, hopefully that's the only
two options for chiseling. If you have like this chiseled JRE is effectively like a, think of it like a Java base image, but that has the chisel stuff baked into it, as compared to going from scratch using the chisel commands like Samir showed to install everything and then go from there. Yeah. Okay. Cool. Yeah. Makes sense.
It's a chiseled version of Ubuntu specifically for the JRE version 8.
Cool.
So the good thing is I did something wrong. So we get to debug. I think I had an L too much. Is that it? Yes. That's a thing, and I hate I don't know if that's actually the thing. I hate the British versus American English here, and I'm going to say that as a native French. I don't get the double L thing. I don't get it.
Oh, now I wish Martin were
so
here so we could have a war about British. Yeah, and the actually, OU thing in colors, I don't get either. Yeah.
Actually, I think we picked the okay, that's my bad then. We picked the British writing, so that's 2 L's. It's just that I was wrong on the tagging. Cool.
I mean, I think we can all admit while that's building that, you know, French is the superior language to anything English. It just sounds better. It is. I don't know French very well, but I will admit that in public. Again, it's a secret between us because I'm an English writer. But I will not voice my opinion on whether American English or British English is superior, though I think we all know. So.
Well, we are all remote companies, so we have everyone from all across the globe, but the marketing or public communication guidance is use British English. I'm not sure why. But that's it.
We'll blame Wimpy for that. We won't blame Martin for that one.
Probably, if you look, yeah.
Yeah, I mean, right?
There was also Poppy that was another one. So the chiseled version is about 100 megabytes less, so that's already 50%. Way smaller. Still big, because it has all the Java runtime environment in it, and the system dependencies that it needs to run. But that's already a great size improvement. Something that I could say here is that the Java runtime, it comes with all it has, so all the SDK that you want to install. We could go further here, and we're actually going to go further with saying specifically I want this part of Java, etc. So there are other optimizations that you could do, but just a drop in size. I think it's already the size you would find if you were to install an Alpine-based one or a distroless-based one.
Yeah, Java images tend to be a little bit bigger on average, and 100 megabytes is about typical for what we see for like an optimized Java image. You know, an unoptimized one tends to be much bigger, you know, in the 500, 600 megabyte category, if it's like a fully baked app in Java. So yeah, that's pretty typical, and a 50% reduction right off the top with just changing the base image is pretty good. So yeah.
Right, so now I want to use Docker. Since I'm not going to install it, I'm going to use, you have a containerized version. So as long as we're doing containers, I'm going to use it. So I have this useful alias for dive already. I don't know if you use it. I know that.
Yeah, we do know that.
Slim also allows you to do some stuff like this. So I'm just going to create something similar that is an alias using the Slim, I think it's called, image you have pre-built available to use the Slim tool, and call it Slim. It's just calling Docker to run it, mounting the local Docker socket, and then calling the image that you have pre-built. So then I can just use the Slim command exactly if I had installed it locally.
Cool.
So that's a hack I like to do for other stuff as well. I don't really like to install stuff on my laptop, so
yeah,
just do that.
That's a great little hack. I We'll have to publish that. I wonder if that's published. I know that there is a little shortcut in the SlimToolkit GitHub repo for that, but I don't know if it's that concise as to what you just did, which is awesome. So cool.
Yeah, but then you can just run it exactly that. So I just run the slim help command and I get it.
Cool.
So now, if I'm not wrong, I'm going to try to remember what I need to do. So I'm going to slim this image that I called, how did I call it? HTTPS Java? Yeah, I think. It's going to be just checking. Oops. That's not what I wanted. Exactly, that's the right name. So I'm going to do slim. I think it's built in the image. And I'm gonna just pass some flag here because the app that we have is just like a kind of hello world print something, not very useful. It's not doing anything. So it's not exposing any endpoint, which usually would have with a microservice image. So in that case, I just pass something to tell Slim that we don't have an endpoint to test.
Cool.
So disabling the probe. And that should. Did I pass which one did I pass? I think I did it wrong. I think I passed the unchiseled one, so I'm going to do it for the both.
Oh, yeah. Sure. Yep. Cool.
And
Cool. So
naming is not our thing.
It's all good. Naming tags is always difficult. I overwrite them all the time. So just for people watching, so what this is doing is it's running the containerized version of the SlimToolkit open source project, which can build a functionally equivalent version of the container, but it runs and sort of observes what's happening in the container and then kind of goes this top-down route to remove anything that's not needed from either the application or from the base image. Now, you're building this from the original kind of 220 megabyte image, but I think what you wanted to show and what we're going to show now is actually doing it from the chiseled image. So that's saying like, hey, this already has a very optimized base image and we know what needs to be in it and these packages. But since we have these like application installs, there's still a little bit of gray area as to what might be in the container, I think is what we're hoping to show here. Yeah, cool.
Is that it right there? Let's see, 87.
Yeah. So yeah, 87 is the slimmed one after it went through the tool from the biggest one. So already there's a bigger size reduction. But what I wanted to do now is to run it through Chiselled one. So combine the two. Okay, that's not what I wanted to do. I wanted to run it. I said not to show it again. Run it, and I'm gonna wait.
Yeah, you're just rebuilding it, but yeah.
So they did for the other one. What can we tell more here? I think. Then we can just compare the size. No, I don't. That's what I'm thinking. We didn't even try them, did we? So we don't know if they work.
Yeah, it's always a good moment to know. So is there? I want to make sure I'm not confused on this. Like, are there two steps with chiseling? Like, so there's using sort of the chiseled base image, but then would you take another step? You would put that like chisel command, or I know Samir had like a chisel command in his Docker file. Is there another step to actually tell it like, hey, take out all the stuff that I don't want, or is that kind of baked into the base image?
No, it is. It is what it does by default, right? It's installing exactly what you told it to install.
Okay.
From the beginning, the right way to do it is not leave chisel in the image in the end. Like you're just using it as a build time.
Got it.
Package manager just to get exactly what you want out of it.
Got it. Okay, cool.
And I think that's cool. Now if we check, yeah, that's actually about the same size. Java is one of the hardest to optimize. So it's a bit sad we don't see a bigger size reduction, but that's not so surprising with Java. But still, there's some sort of logic when you look at the results. Like the biggest one is just the default one. We did nothing to it. Then you have the chiseled one, that removed a big part of the distribution. Then we have the slim one from the bigger one that is already very optimized. And then the slimmed and chiseled that is a tiny bit smaller. So in that case, you guys did a great job. And Java 8 did a poor job. So ideally, in some other cases, when you're using something that doesn't call all the libraries at startup, basically, or something that is how to say, less monolith.
Yeah.
That should be even smaller. Then you should have a real scale of the last one is like 60 megabytes in that case.
Yeah. Well, you're highlighting something really cool, I think, which is that, like, we talked about it kind of at the top of the hour, which is like, okay, people always want to have like these trade-offs, right? It's like, oh, should we use Alpine or should we use this thing? Or should we use distroless or should we use this thing? And like they treat them like people kind of treat them like binary decisions, like, okay, I'm going to do this, so I'm safe. But the truth is, like, all of these tools can work and interact together. And so putting together a program to like both have a really, really good developer experience like you get with Ubuntu, but then also have, like slim, hardened, like only what you need for production ready, secure containers. Like it takes more stuff. Like even this 200, right? Like whatever that 200 kilobytes is like, well, what is that? Why was that there? It's probably just decisions that people have been making at different places in the, kind of optimization flow. But they matter at the end of the day, And so I think it's really cool. It's a really cool example of showing like, hey, you can get more out of this. And depending on the framework, these numbers can have different magnitudes. I'm guessing that if this were a node image, like we'd see both a bigger change in each of these different stages, and like the end image would be much smaller, which is cool to see. I was thinking about one other thing that you just said. I'll come back to it, but curious other thoughts. And if people have questions, please drop them in chat. I think this is a really cool demo. So
yeah, this was awesome. And I'm glad that you showed you went through this without using the chiseled version first, actually.
It's good. So now we have the whole scale of sizes. That's very
the whole comparison.
Yeah. One thought I had, you brought up Dive, which is an awesome like open source tool, and a lot of people use it. I will say on the Slim platform, so if you go to Slim.AI and you log in, actually one cool thing would be to actually do this, and then we have a container diff tool on there that allows you to see the differences between the different containers, and we could actually like kind of go in and sort of compare these containers. It's also might be a cool thing to just kind of look at sort of the original images versus the chiseled images. So if people want to get a sense of like what's actually happening with chiseled images, you can go in there and compare, push both your original and your chiseled version up to some registry that you have access to, connect it in the Slim platform, then you can use that diff tool to see the difference between the two. And that's pretty cool. It like really kind of brings home like, okay, well, like what was actually removed in this? Well, probably a lot of those documents like you showed, Valentin, and maybe some binaries that weren't going to be needed, like ls and stuff like that. But if people really want to get a list, that's a good way to do it. So
that's a cool version for v2 of this demo. I think
having
the diff would be very helpful to understand the process. It's also a bit tricky because between the not slimmed and the slimmed one, the diff really makes sense because it's really like there's a step 1 and step 2. Between the not chiseled and chiseled, I think it would be interesting to look into it, but it make a bit less sense because you didn't go from step 1 to step 2, right? It's just you took two different approaches when building the image. One you used the full distro, and the other one you built a new distro from scratch, basically. So yeah.
Okay.
But you would still see a difference. So that's interesting because the paths, the file paths are the same within the image, of course, for compatibility. So you would still see an interesting diff.
Okay. Yeah. But it wouldn't be like the traditional diff that I have in my mind right now, which is like this was in step 1 and then it was removed in step 2. It's like going to be like a net new, different kind of distribution. That's really cool. Okay. I definitely feel like we have another Twitch stream to kind of go over that. So yeah. Cool.
Yeah, actually, if you went into the image itself, you see that it has just one layer basically. Like you don't see a reduction in size of layers, and it's just a file system like you would have in any Linux. simplistically.
Cool.
So yeah.
Cool.
But yeah, I agree. Like good V2, good idea for V2 to have a clear diff on screen. That would be nice.
Awesome. Sounds good. Well, cool. That was fascinating couple demos, you guys. Thanks for putting those together. I'm so glad we were able to learn a bit more about the Chisel project. Martin and I were talking about it a year ago, and maybe not a year ago, but like I think when you published that blog post in August, Martin sent it around, and we said, "Oh man, we gotta get this on stream and see what these guys are up to." So,
That's really cool.
demo.
Thanks for having us over.
Yeah. What else? I know you guys have another project, Rockcraft. Just like quickly, what's Rockcraft all about, and how does that kind of complement Chisel, and how is that different?
Right. Yeah. The reason we mentioned it is that actually Chisel kind of came along Rockcraft, because the first thing that we had in mind is we wanted to build a declarative framework for building these container images, because we are building a lot of images and we are going to build a lot more images at Canonical for Ubuntu and for different kind of applications. We already have a few available on GitHub, on Docker Hub, on GitHub as well, but Docker Hub.
Mm-hmm.
And like what we really want to do here is track what we have in these images and have a very clear understanding on what we're shipping and how to patch. Like I don't know if there's a log4j again, in one snap being able to say like that's exactly what we need to fix and downstream or cascade all of this. So we're building this declarative framework that's Rockcraft. It's similar to what we have for snaps, the Snapcraft tool, hence the naming. But that outputs OCI images instead of snaps in that case. And yeah, Rockcraft is driving Chisel. So you can use Chisel in the Docker file. You can use Chisel in anything actually. I mean, if you wanted to use Chisel in even on your on your non-containerized OS, you could.
Okay.
But then yeah, Rockcraft is able to drive it. As I think Samir was saying before, like the biggest difference that you would see is that you don't have to care about multi-stage builds, because it's a declarative framework. So you're just saying, in my final image, this is what I want. You listed the slices. It's a YAML thing, and you get the image. But that's still very early, even earlier than the Chisel tool. So yeah, maybe something for another one.
Okay. Sounds good. 4 to 6 months. We'll Google remind me in 4 to 6 months. Nice. Awesome. That sounds good. Well, cool. Thank you guys so much for coming on. Where can people find you guys if they want to learn more about Chisel, if they want to connect with you guys? Like, what's the best way to get in touch with you guys?
For me, it's on LinkedIn or GitHub. On GitHub, I have my email, or LinkedIn for me.
Oh, okay.
Yeah, actually, you can find all of the engineering team on GitHub. We're doing most of the work in public, so you just see who is contributing there, and that's the team. We all have weird names. No, I mean, I do have just my normal name, but that's because I'm not an engineer anymore. All the engineers, they all have fun names there.
I don't know. You came on and did a pretty slick demo, Valentin, so I think you get engineering credibility at least. Awesome. All right. So bump over to the Canonical GitHub, and you can find Samir and Valentin over there. You can also find ways to contribute to the Chisel project, or fork the project and start creating your own chisels, which is pretty cool. That sounds awesome. Nina, what are we up to next week? I don't think we have a guest next week. I think they bailed. So I think we might be back on our GitHub action. Is that right?
I believe so. I think where we left off, there was more that we wanted to look into with that.
Yeah. And you admitted to me after the stream last week that you actually were being a little modest in how well you know GitHub Actions, and that you actually have some experience with them. And so I might be leaning on you to actually code the GitHub Action next time, since I don't.
Nice. So. Let's do it.
All right, perfect. Well, sounds good. Well, with that, we'll say thank you to Samir and thank you to Valentin from Canonical, and thanks everybody for joining. We will catch you next week, same time, same place. So thanks all.
Thank you.